All right. Now, here is the deal, okay? If I ask you, what is 2 plus 2, okay? What would be your answer? 4? Okay, so this is mathematics. You asked me this question, right? 2 plus 2, Dr. Ali, 2 plus 2, how much is 2 plus 2? But please answer as a statistician, okay? Answer as somebody who follows statistics. Then the answer for this question would be 2 plus 2 is equal to maybe 4. Okay, why? Because statistics, normally why we use statistics is to really capture the probability of things, right? None of the stuff around us have 100% chance of happening. You know that even though this example is not a good example, it's a scary example, but still I'll mention it because I just want you to think about how much is the probability or how much is the chance of something like this happening. We've had cases where in the airplane crashes, airplane crashing down, people survive. Now you think about how much is the chance of that happening, right? It's a very minute chance, but it's a chance. And that's why we go beyond mathematics and really talk about the chance of happening something or the probability of happening something. And that's where statistics come into the picture. Alyssa, you recently got married, right? So let me ask you this question. Because you recently got married, in your opinion, give me 3 or 4 things or qualities or characteristics that you are looking for in your husband.
Oof, okay. Compassion.
All right, hold on, please, hold on. Okay. Compassion.
I'll say ambition and loyalty.
Okay, so this is basically your dependent variable. And we need to think about some independent variables, some variables that determine your dependent variable, right? So in this case, Alyssa's perfect husband, the definition of perfect would depend on 3 things: how compassionate is that person, how ambitious is that person, and how loyal is that person, right? So these 3 things would determine the perfection of the husband for Alyssa. Now, if I change this example with something else, now paying tips, right? Now, in the US, normally paying tips is sort of a must, even though nobody says it's a must, but it's sort of a must. But in some other countries where it's a logical thing, right? You pay tips if you're really happy with the service, right? That's why you pay tips. So there's some determinants of why would people pay tips, right? If you think about what are those determinants, we can say service, right? Service, maybe let's say service speed of service, and service quality, staff empathy. How empathetic was the staff, right? So if the staff was empathetic, if the service quality was there, and the service had speed, then people will have inclination to pay tips, right? So no, right? Now, this is what we need to capture into statistics, right? So you think about your research questions or research problems that you're focusing on. You have a dependent variable, you have a bunch of independent variables, and you want to see whether these variables will have an impact on your dependent variable or not. This is what we do, right? Now, if you, let's say, Gizam, your topic was what? Can you please tell me?
Relationship between the voice assistant's personality and customer's trust.
Voice assistant's personality and trust.
Yes.
Right? This is what
yes.
you have. Okay. Now, there's nothing wrong with this model. It's fine. You want to look at voice assistant's personality and consumers' trust towards the voice assistant. So one way is, I mean, if you just go with this one thing, voice assistant personality and customer trust, this is one hypothesis. So usually it may not be a good idea to only have one hypothesis and going into your paper or any research project or whatever. And I'll tell you why. Because when you think about trust, let's say I have an Alexa in my home or Siri or any voice assistant in my home. Do I trust that assistant or not? This is what your main question is, right? Like, what would make people trust this voice assistant? So, of course, personality is one, right? Personality is one thing. But what other factors also determine this trust, right? Voice assistant's accuracy, how
Yeah,
accurately
being
it is,
informative, accuracy.
right? Informativeness. Then also I've seen some people who also study some unique variables, like let's say humor, but humor can also be part of personality, right? So you can think about
Yeah.
it like this, right? So think about what are the factors that determine consumers' trust towards voice assistants. So the first thing you need to determine at your model stage when you are developing your model is what type of relation do you want to see between two variables, right? So there's two type of relations, okay? Remember, one is called unidirectional and one is called bidirectional. If I have a variable called A and B, and if I'm looking at a relation like this is unidirectional because it's one direction of the relation I'm showing, right? But if it is like this, then we call it bidirectional because the direction is both ways. Okay. Now, when do we use them? So remember, if you are looking at the relation between two variables, like this one, we call it correlation. Okay, why? Because you are looking at how these two variables are related to each other. Okay, this is called correlation. So you can think about it like spending and saving. Think about it. If you have $1,000 into your bank account as saving, this saving will determine spending, right? If you save more, you spend less. If you spend more, you save less. So they are both connected to each other. And the relationship between both of them is bidirectional, and we call it as correlation. Yes. Now, in some cases, we don't have a correlation. We don't have two variables impacting each other at the same time. If we are talking about luxury products, in luxury products, your satisfaction would lead to loyalty, but a particular type of loyalty. Okay, you don't keep buying things again and again because they're luxury, right? The consumption is limited. But you can become more of a attitudinal loyal, meaning you tell your friends about it, you tell your family about it. But by telling friends and family, it doesn't increase your satisfaction. So in this situation, the relationship is unidirectional. So it's not a correlation, it's a unidirectional relation. So again, remember the relation between two variables would depend on which context are you studying it. The whole idea here is correlation. Correlation exists when two variables impact each other. They are tied to each other. Remember, whenever you analyze your data for correlation, there's two things you need to check. Okay, one is strength and the other one is direction of the relation. So this is what we are talking about correlation. Okay, so remember for correlation, correlation is between two variables and it looks like this. And when you run correlation analysis, which I will show you how you run it, is the results are going to show you two different things. Okay, and both of them are very important. One is strength of the relationship. The other one is direction of the relationship. Now, let me first go with the direction of the relationship and then I can explain to you what is strength of the relationship. So whatever, let's say you run the analysis and you get an answer, right? So remember the result for correlation, like we call it correlation coefficient, the number for correlation. In this situation, the correlation between satisfaction and loyalty, the answer will always be between plus and minus 1. The answer cannot go outside of it. It can be either between plus 1 and minus 1, right? So it can be 0.5, 0.6, 0.8, whatever, plus minus. It would be like this. Now, if the answer is between 0 and plus 1, we call it positive relation. Positive relation means that if you increase the level of satisfaction, the level of loyalty will also increase. This is what positive correlation looks like. Okay, you increase the value of one variable, the other one will also increase. For example, the amount of sugar and sweetness. The more you put sugar, the more sweet it will become, right? So it's something like this called positive correlation. If the value is between 0 and minus 1, we call it a negative relation. And what negative relation mean is if you increase one, the other one will decrease. Like spending and saving. If you increase your spending, your savings will decrease. So this is what the direction of the relation is, positive or negative. Now, what is the strength of the relationship? So basically what it would look like is that if your value is between 0 to 0.5 plus minus, right, either way, we call it as weak. This part and this part, like 0.5 to 1, we would call this one as strong. And what strong or weak means is this, very simple. So if let's say my relation is strong, right, strong relation, it means like this. If you increase satisfaction a little bit, the loyalty will increase a lot. The weak one means if you increase this a lot, this one increase just a little bit. Or if you increase one a lot and the other one decrease a little bit, it's still weak, right? So weak and strong. Now, obviously the numbers would always be between 0, plus 1 and minus 1. So let's say if I want to test the relation, the correlation between satisfaction and loyalty, and my result are 0.692. So what do we say this one? So first of all, there's no minus sign with it. So it's a positive one, meaning it's a positive relation. Correlation, but is it a weak or a strong one? So if it's higher than 0.5, we would call it as a strong positive correlation. We understand the strength of the relation and the direction of the relation, but then the third thing, which is very important in statistics, right, is also something called as significance, right? So if the p-value is equal to 0.05 or below 0.05, then this number is accurate. But if your p-value is higher than 0.05, then this value doesn't mean anything. Okay, so this is the whole idea behind correlation. Okay, so this is also very important to understand. Okay, so remember that when you are collecting your data, right, let's say in this situation, I have this performance expectancy, this is my variable. So if I want to do correlation or regression, I want to do it between variables, right? This variable and another variable, so between two variables. But how do I measure performance expectancy? I measure it through 4 questions. Yes, I go to my questionnaire. In my questionnaire, there's 4 questions about performance expectancy. So I'm using these 4 questions to measure performance expectancy. Yes? Now, in SPSS, what are we doing? So when we go to SPSS, how do we input data? We input data for this question, this question, this question, and this question. However, I actually need the value for this one to do the correlation. So in this situation, if you look at your SPSS, usually what we do is for each variable, let's say in this situation, this variable, if you look at it, let's say, all right, let's say this one, BAR1, BAR2, 3, 4, 5, 6, 7, 8, 9. This variable is called barriers. Name of this variable is barriers, but for this barriers, I used 8 questions. And if you look at these questions here, it says robots consumes too much electricity, robots malfunction during a service interaction, robots can misunderstand a question, blah, blah. So these are 8 questions that I use in my questionnaire, right? How do I convert these 8 questions into one variable called barriers? This is important because you're going to do this one into your study if you analyze the data. So what I need to do is very simple. Here on the top in SPSS, you will see something called transform. Do you see this? Right? If you go to transform, the first one is called compute variable. So all I need to do is compute a variable. Okay. So here in target variable, I'll just name this variable called barrier. And here, how am I going to compute this barrier? Very simple. I just need to take an average of all those 8 questions because those 8 questions are measuring barrier, right? So if I take an average of all of them, it will give me one variable called barriers. So I click on this all, and here are all the formulas. So all I need to do is go and find mean. This is mean. I double click it. And then here I need to create the formula. So what I need to do is just double click on these questions, barrier 1, comma, barrier 2, comma, barrier 3, comma. So I put all those 8 questions here and I take a mean of them. I click on OK. And as soon as I click OK, you will see there's a new variable here, barrier. If I go to the data view, I look at this barrier. These are all the mean scores. Now I will also create another variable called intention. So now I have 3 variables here, barrier, intention, and head and neck, right? And let's say I want to find out the correlation between these 3. Here, analyze on the top, okay? Analyze, right? And here, down here is correlate. And then I go here to bivariate. Okay, bivariate simply means more than two variables. So I'll go here, select these 3 variables, put them here, okay, and that's it. Just click on OK. So this is the table for correlation. All I will do is just copy it. Okay, so how do you read this one? So the first thing is, this is the value that I was talking about for correlation, this one, right? So it says Pearson correlation. This is the value for significance for 0.05, and n means how many respondents I have. So in the data set, I have 552 respondents. So in this situation, I don't need this one. I'll just remove this one so it becomes easy to read the table. Okay, and then do you see here is 1, and under 1 there is nothing. Then there's another one here, and then there's another one here. Yes. So what does this n1 mean? If you look here, there's a variable called barrier, and there's a variable called barrier. So this one actually shows us the correlation between barrier and barrier. And because it's the same variable, this correlation will always be a perfect correlation because the same thing. It's like you look at yourself in the mirror, right? If I'm interested in understanding the correlation between intention and barrier, what will I do? I will look at this number. So what is this number? Minus 0.324. So minus means it's a negative correlation, and 0.324 means it's a weak relation. So it becomes a weak negative correlation. Yes, so you have the direction and you also have the strength. But then here, we also have significance, which is less than 0.001, which means that it's less than 0.05, right? And then because of that, we will always say that this number is accurate, meaning this number stands. So this is the correlation between intention and barrier. All right. Okay, so this is correlation, and then regression is pretty much like this, just one more thing in regression. Okay, so in this situation, now you have a model like this where you have a bunch of independent variables. You want to see how they impact the dependent variable, right? This is what your model looks like. But remember that this model doesn't have correlation because these variables do not correlate. Like personality can have an impact on trust, but is trust also impacting personality? Maybe not, right? Accuracy can create trust, but is trust creating accuracy? Maybe not. So there's no correlation. These are all one-sided relations. Okay, all one-sided. Now, in this one, we again look at strength and direction of relationship, just like correlation, right? Strength and direction. Now for direction, it is still the same like correlation, plus and minus. If there is no sign, it means it's a positive relation or positive impact. If there's a minus sign, then it means it's a negative impact, right? It's exactly the same. Now, when it comes to strength of the relationship, there is no plus minus 1. In correlation, there's plus minus 1, right? However, there's one other thing, and it is relative strength of relationship. Okay, what it means is for you to say which relation is strong and which relation is weak, you need to compare these relations against each other. So it's relative, meaning, whatever values you get out of it, you need to then look at those values. The highest value would be the strongest relation, and the lowest value would be weakest impact or the weakest influence. The other one is also about your dependent variable. Now remember, in correlation, there's no dependent variable because both of them are impacting each other, right? So there's no point of saying dependent variable. But in here, we have a dependent variable, which is customers' trust or consumers' trust, right? So other than relative strength of relationship and direction of relationship, the third thing, which is very important in regression, is also coefficient of regression, or sometimes we call it R square. Now, normally R square is always a percentage value. So let's say you do your regression, you do all these things, and then you get a R square for consumer trust as, let's say, 73%. Now, what does this 73% mean? It's very simple. But before I explain this, I'll give you a very simple example so you understand it, okay? Let's say that you want to make a sandwich, Subway sandwich. Obviously, after you go through the whole queue in Subway sandwich and then you try to eat it, right? When you take a bite out of your sandwich, there's a taste, right? You taste it, right? So this taste is made up of a lot of things. It's made up of the bread you chose. It's made up of the type of fillings you chose, or vegetables or sauces, or whether cheese, or whether you, whether you toasted it or not. So all those things would determine the taste of it. Yes. So regression is like that. What we are saying is here that this consumer's trust is made up of all our independent variables. So all our independent variables are creating consumer's trust, right? But you think about it as a consumer, do you think these three independent variables are the exclusively all the things that would create consumer trust, or there might be other variables also? Do you think there might be other variables that also create or determine consumer trust, but you didn't include in the model? We create a model, but we always remember we cannot put all the variables into our model. Like, it's not possible, right? Sometimes you
Otherwise,
don't.
it's going to be too much, and we
Yeah,
need
it's too
to
much.
explain all of them.
Exactly. Plus, we may not know them, right? Because we are talking about consumers' trust. So remember, let's say if I am asking question, 500 people are responding to me, right? I create the model based on my understanding and my knowledge, but people who are going to respond to me may be thinking completely differently. Maybe for them, there is other important factors that I didn't think about, right? So in this situation, what we are saying with this 73%, what is coefficient of regression, or R square, is that if there is a 100-degree change in consumer trust, meaning that if consumer trust increases by 100%, 73% would be because of these three independent variables, or these three variables in my model. 27% of the change, like the remaining one, right? 27% is because of some other variables that we don't have in our model, maybe other than whatever. And this is why whenever you read a paper and you go towards the end of the paper, so if you look here in this paper, what it says is something interesting in the limitations, right? So it says that we looked at some stuff from the task environment and measures, and then maybe future research should investigate the adoption of other systems and some other variables and some other relationships and blah, blah, blah. Now, if again, if let's say I have three independent variables and they are impacting my DV by, let's say, 73%. So we understand this one, right? We understand what is 73%. The other one is, again, let's say plus 1.92 minus 6.73 minus 0.197. So these values can be anything. Again, plus minus simply shows the impact, meaning one is a positive impact. It means that if you increase the level of 1, DV will increase. 2 is a negative impact, which means that if you increase the level of 2, DV will decrease, meaning consumer trust will go down. 3 is also negative. Again, it means a negative relation, but where is the strongest and the weakest one, right? So if you look at these numbers, usually this plus 192 is higher than minus 6.73 in terms of scale, right? Because plus 192 is a positive number, minus 6.73 as a negative one. So obviously 1.92 would look higher. However, in terms of relative importance, this would be the most significant one, meaning the most important one, because even though it's negative, but the number, the 6.73 is very high, meaning it's strongly negative impact. Okay, so those are the three things that you get in regression: the direction of the relations, the relative importance, and then the coefficient of regression, or R square. That's all. This is all you get into regression, nothing else. Okay, let's do this one in SPSS one time and see what do we get, and then from there we can. Okay, if you look at my variables here, I have a bunch of variables: barriers, intention to use hedonic, social impact, and insecurity. 5 variables. In this situation, I have intention to use as my dependent variable, and then the rest of them are independent variables. So I go to analyze, okay, and in analyze here is something called regression. Okay, in regression, the second one is called linear. So I click on linear. All right, once I get here, now if you look at here, what do we have? On top, we have dependent, right? So this dependent is our dependent variable, which would be intentions. I'm just going to put it here. And then the rest of them, these variables are my independent variables. So I'll just put them into independent. That's all. And I'll just click on OK. All right. So once I click on OK, what do I get? So the first table here, if you look at this table, it shows, if you look at here, it says that in your model, your dependent variable is intention and your independent variables are insecurity, social, barrier, and hedonics. Okay. The first thing you see here is R and R square. So this is your R square, which is 0.412. If you make it into percentage, it will become 41.2%. So if you look at this one, let me bring it into here. Okay, these are important, right? So these are my 4 independent variables: barrier, hedonic, social, and insecurity. These are your beta values, which is the relative importance. Okay, so you can see the first one is a negative relation, then positive, positive, and negative. And then obviously you can compare these numbers to see which one is the highest, which one is the lowest. So right now, insecurity is the lowest number, and then social factors is the highest number, right? So that shows you the relative strongest and weakest influence. And then these are your significance values, which are all below 0.05. So you can say that barrier has a negative impact on intention, meaning that if there are higher level of barriers, people will have less intention to use robots. Then hedonics is how much do you enjoy interacting with robots. So if you have more enjoyment in using robots, then you will have a better intention to use robots. Social means what is the social acceptance? If people around you are happy with robots, if they have positive feedback about robots, then you will have a higher intention to use them. And insecurity is how insecure do you feel yourself around robots. If you feel very insecure near a robot, then obviously you will have a less intention to use it. So that's what your these numbers and these results show. Okay, I'm going to stop here.